Hi Year 11s, welcome to the next video in our topic of linear equations. We are looking at linear graphs at the moment, which is chapter 6. Today what I'm going to show you is how to find the equation of a straight line. First of all, we're going to look at the intercept and slope. So how do we get the equation if, say, we're looking at the graph? And the second thing I'm going to show you is a nice little strategy. Actually going to use the calculator for that, and that's getting the equation from 2 points. As long as you've got 2 points, you can generate the equation, and I'll show you how you best use your calculator for that. Going back to the previous page, which is where I'm going to start, we know that our equations, our straight lines, they're going to be in this form, y equals a plus bx. And importantly, the a value is our y-intercept and the b value is our slope or our gradient. And so with these first few examples, I'm going to show you how to get the equation. We're just going to identify a, so we're just going to get our y-intercept, and we're going to find b using our slope formula, and then we're just going to put that together into the rule. So as an example, with this first one, you'll see that I've got the y-intercept because I can see that it's passing through this point here, which we would call 0, 1. So x value of 0, y value of 1. We have a second point over here. And what I'm going to do is call that x1, y1, and this one over here I'm going to call x2, y2, and that's just so that I can get my slope. So the a value, that's our y-intercept, I can see is 1. So that's one part of the equation that I need. The second part that I need is our slope, which we know we can find looking at the rise and the run. And so if I use this over here, I've got 1 take away negative 1, oops, like so, and that's over 0 take away, so 0 take away negative 4. Okay, so this comes out as 1 plus 1, and this comes out as 0 plus 4. And that simplifies to a half. So what that means is I've got my a value of 1 and my b value of 2. So therefore, my y, I write my a first, and then my b values, and that of course is being multiplied by x. So my equation of this line would be y equals 1 plus a half of x, or 1 on 2x. So there's one example. I've got a couple more, so I'll just quickly show you those before we look at the calculator method. First of all, I can see my straight line here. I've actually got my intercepts, so I just identify them by writing their coordinate. This is an x value of negative 3, y value of 0. I'll call that x1, y1. And this one over here is 0, negative 2. Again, x2, y2. So start off with your y-intercept. I can see that that is negative 2. And then for the slope, as usual, I do my slope formula. All right, so that will give me negative 2 take away 0 for these two values here. And 0 take away negative 3. All right, so negative 2 take 0 is negative 2, and 0 plus 3, so negative 2 on 3. So I'll just go up here. This just means therefore, oops, if you see me do these little triangle, therefore y equals negative 2, and since it was a negative slope here, I make sure I put minus 2 over 3x. So there's our second one. And finally, if you're doing something similar to this, again, 0, 1 is this coordinate. This one over here is negative 2, 0. So I'll just go x1, y1, x2, y2. Our y-intercept, as you can see, is 1. And our slope, we've got 1 take away 0, and then we've got 0 take away negative 2. So it gives me 1 over 2. So just by a fluke, we happen to have the same equation as the first one. So y equals 1 plus a half of x. So that is one strategy for you. That's, of course, you have to have 2 points with that because you do need to be able to find the gradient always. And you also do need to be able to see your y-intercept as well. Now, there's another option for you. So I'll show you that one now. Well, there's 2 options actually, because if you have a look at the very next page, you'll notice this is titled Finding the Equation from 2 Points. Now, we technically did that in the previous examples as well. We had the y-intercept shown to us, whereas in these examples, you're going to see that we can't see the y-intercept. It's not been marked on the graph, which is why that previous skill that I was just showing you wouldn't apply, it wouldn't work here. I do need to know what that value would be right there. So if you come across something where you've got 2 coordinates, you don't know the intercept, so you can't do it sort of that fast way like I did just before, what you'll do instead is use your calculator. Now, what you will notice is there's a box here that's got, a set of instructions that says the by hand steps. Now, this really is optional because that is there because a lot of you may have done maybe pre-methods last year and you can do this very quickly. Some of you might be able to do this very quickly by using the coordinates to get the slope and then doing a substitution into y equals a plus bx. You do that and then you can solve for a and then that can give you your equation. There is not going to be the preferred method for a lot of you. So what I'm going to show you is the calculator method instead. Okay, so optional, doing it by hand, but for a lot of you, calculator. So your first step always is to identify 2 coordinates. Now you notice I just wrote one down just before because I don't want it just as -2. I want it in its coordinate form. And the other coordinate is shown to me already, 1, 7. So the trick is with this is to open up your calculator and go to your Listen Spreadsheets page. What we do is we label one column as X and the other column as Y. And so what this does is allows you to put a coordinate in these 2 boxes. So for example, that first coordinate, which was -2 and 0, doesn't let you go sometimes it doesn't let you go sideways. That's why I sort of went like that. But that means that our coordinate is listed across the row. So I've got my X value first, then my Y value second. You'll then put your second point in. So my second point was 1, 7. So that will go in like this. So -2, 0 and 1, 7. Your next step is to press Control-I so that we open a new tab. And the tab you want is Data and Statistics. Now, I know we haven't used that in this topic, but I'll show you why we use it. It's because we can plot. It's because we can plot these 2 points. So once you've got your Data and Statistics page open, click Add Variable, and that's our x-axis. So we'll add x along the bottom, and then we'll put y along the vertical axis. And all it does is it plots those 2 coordinates that we've got, that our line is passing through. The next thing we do is we use something called regression, which is connecting data points with straight lines. And that's essentially what we want to do. We just want to draw a straight line through these 2 points, and it will tell us the equation of that straight line. So we'll go Menu, 4 for Analyze, 6 for Regression, and then we want this one, show linear a plus bx. Now these instructions are in your notes. I'll show you in a second, so don't worry about frantically writing down the steps. I just want to show you for now what it looks like. So generally with this one, it would probably have come out as a fraction if we had, well, it would have come out as a fraction if we'd done it by hand. But what you can see here is we do get some funny numbers here. We've got 4 2/3 and 2 1/3. All you need to do is just use your little recurring symbol. That will be fine. It's not wrong to leave it as a decimal. So what we've got is y equals, this is our y-intercept here, our a value, so 4.6 recurring, and 2.3 recurring is our slope. So if I go back here, I'll now be able to write my equation. Y equals 4.6, we put a dot above it, and 2.3, put the dot above it, and that's being multiplied by x. So that there is the equation of this line. So as you can see, it's fairly straightforward. There's not really much that we need to do, but like actually written. You'll see there's a lot of space here, but that's only if you want to use the by hand steps. You're not going to be asked though to do that by hand. So if you prefer the calculator method, that is what you should be using. Just to let you know as well, the steps that I just went through are just here. So you'll notice we've got entering the coordinates, getting into data and statistics, and then you'll see the buttons I press was menu, analyze, regression, show linear. So you can, it's menu 462 if you want to do it is a speedy way, menu 462. So I'll just show you the last few and show you how fast it is actually. Once you've got it all set up, you can just change these coordinates and then it will update your equation. So with this one here, I've got my 2 coordinates. That's what I'm going to enter into the calculator. Now, if I just go back to 1.1, I can just change these. So -1, 2, like that, and then 5, -1. Now, when you go back to the other page, it'll look a bit funny because of the scale changing. So all you have to do is just re-enter either your X or your Y. So what you'll notice it's done, it's, now if you need to, you can click and drag that just so you can see it a bit better. Y equals 1.5. Now it's got plus minus 0.5x. I'll just explain that in a second. I'll just get it onto the page first. Now the calculator, because it's using obviously a particular default system where it just it has this template and then it just puts in the A and the B values. That's why it's got this funny looking thing here, the plus minus. Now, really important that you never leave it like this because that's not how we would write. That's not really simplified at the moment. What you want to do is if you see that that slope is negative, rewrite it so that it says 1.5 minus 0.5x. Essentially, this is adding a negative, and that's the same as subtraction. So that's what we want to see you do. So please don't leave like that. I might just put a little box around it. Please don't leave it like that. Please make sure that you simplify it, because it's really not good practice to leave it as plus minus. Also be very careful too, because you'll notice that the negative is very small. It's easy to miss, but I can see that this has a negative slope, so I know then that I should have a minus there, or for minus the bx. So the last couple of examples, if I just speed through these couple so that you can then have a go. Sometimes instead of being given a graph, you might just be told a couple of points that a line passes through. So again, nothing different really, because it's actually easier because you've been given the coordinates, you don't have to work out what they are. So if I put that in now, the first one was -1, 5, and the second one was 1, 0. So again, I'll just flip back to this page. You'll see the scale is all messed up. So I'll just re-enter my X or my Y just so that I can see it. But you'll notice it doesn't even matter because the equation automatically updates, and there it is there. See, it is negative and I can see a little negative in there. So again, just make sure when you do this, this is what it looks like in the calculator. But I won't leave it like that because it's not good practice. I will write it as 2.5 minus 2.5x. So just by coincidence, I happen to have a and B value that are the same. That can happen. Finally, you can get something that's worded here. So look out for these sorts of ones. This is one where you're given a scenario, but you're told 2 pieces of information. So your clue is that these 2 pieces of information will help you generate the coordinates. So just write that little note and we'll generate it here. So we've got Amanda at a park. She noticed that she could model the flight of bees from one tree to another using a linear equation. Now, importantly, we look at what each thing means. So the distance is y, and the time is x. Okay, so if you have a look here, a particular bee started at time 0 and the distance was 0. So that's just the beginning point. Now the time was x, so I've got the time first, and the distance was 0, so that's our y. So we've actually got a coordinate there of 0, 0. Now the second part says the bee flew for 2 minutes, so that's my x value, and the distance was 50 meters, so that's my y. So I've got a value here of 250. Okay, so I've actually got my y-intercept there. So you can do it that way if you wish, and you could then use this to get b, these two coordinates to get b. Or calculator method, I can simply go 0, 0 is my first coordinate, and 250 is my second coordinate. I'll go back here and I'll adjust it, and you'll see I've got y equals 0 plus 25x. Now again, this is not how we would leave it, because we don't write this. We don't write 0 plus 25x. We would write it as just 25x. When we don't see a y-intercept there, it means that the y-intercept is in fact 0. And so we've got our equation there, and it would be likely if we were doing this, say, in an assessment scenario, that the question wouldn't end there. We'd probably have to use that equation then in subsequent questions. So I'll leave it there so you can get some practice, but please remember, if you prefer that calculator method that I've shown you that's very quick, you are absolutely allowed to use that method.